Section 3.5 is operations with matrices. A matrix is a rectangular array of numbers arranged in rows and columns and enclosed in brackets. This is matrix A. It has 3 rows, and the rows go across, and it has 4 columns, and the columns go up and down. We say that this is a 3 by 4 matrix. These are its dimensions, so it's the number of rows by the number of columns. Each element or number in the matrix can be described by its position in a row and in a column. So the value of A sub 3, 2 is -8. -8 is the number that's in the 3rd row and the 2nd column. To add or subtract matrices, we add or subtract their corresponding elements. However, the dimensions of the matrices must be the same. If you're going to add a 3 by 4 matrix, it has to be added to another 3 by 4 matrix. To multiply a matrix by a scalar, that is a constant, multiply each element of the matrix by the number. So let's take a look at a couple examples here. Use matrices A, B, C, and D to find each of the following. So the first one we want to do is find matrix A plus matrix B. And just to make it a little easier, I'm going to copy them here. And a hint for when you're copying matrices or writing them out, be sure you give yourself enough space between the elements in the rows and columns, because I don't want it to look like a 2-digit number in this case. Okay, so to add these two matrices, I'm just going to add their corresponding elements. So 6 plus 8 is 14. -4 plus -1 is -5. 3 plus -2 is 1. And -5 plus 7 is 2. Let's do example number 2 here. Matrix C minus B. So let's go ahead and copy those. And we're going to subtract. Okay, so I have -4 minus 8 gives me -12. -6 minus a -1 gives me a -5. 12 minus a -2 gives me 14. And -7 minus a -7 gives me a -14. And example number 3, matrix A plus matrix D. And as you can see, matrix A is a 2 by 2, and matrix D is a 2 by 3. It has 2 rows and 3 columns. Therefore, it's not possible to add these. They don't have the same dimensions. The matrices do not have the same dimensions. Okay, let's take a look at a couple more examples here. Let's do -3 times matrix B. Matrix B was 8, -1, -2, and 7. Let me check and make sure that's right. There we go. Okay, so this is kind of like the distributive property. That -3 gets multiplied by each element in the matrix. So that's going to give me a -24, +3, +6, and -21. And my last example here, I'm going to do 4 times matrix A, which is 6, -4, 3, -5. Let me check that real quick here. Okay, -2 times matrix C, -4, -6, 12, and -7. Let me check that one also. Okay, So first step is to multiply each matrix by its scalar. So 24, negative 16, 12, negative 20. And there's two ways you could do this. You could multiply by 2 and then subtract the matrices, or you could multiply by a negative 2 and then add the two matrices. And I actually think that's what I'm going to do, because I tend to make fewer mistakes when I'm adding than when I'm subtracting. So I'm going to multiply each one of these by a negative 2. And now let's add the two matrices. And there's my final answer.